For this circuit, we want to write a set of equations from which you can find this voltage V. We need to use nodal analysis, but we don't have to solve the equations. We simply have to write them. First job, of course, is to define a reference node. I think I'll try putting mine down here. Now I need to define independent and dependent nodes. I'm going to redraw the circuit, killing the voltage sources and the current source, replacing the voltage sources with short circuits and the current source with an open circuit. Now, shorting the voltage sources converted this node, my reference node, this node, and the node above the 12-volt source into one big node. So this node and this node are going to be dependent nodes. There's also an independent voltage here. I can have a voltage difference between here and any adjacent node, and an independent node here, since I can have a voltage difference between that and any of my other nodes. So let's call this VA and this node here VB. Now I need to assign the voltages at the dependent nodes. If this voltage is 0 volts, the voltage up here is 6 volts higher than 0. So this voltage becomes 6 volts. The voltage over here above the 12-volt source is going to be 12 volts above this voltage, which is 0 volts. 0 plus 12 is 12 volts. Now I can do KCL at nodes A and B. So I'm going to define all of my currents at node A as being leaving that node. Positive will be leaving. The current through the 3 ohm resistor is VA minus 12 volts, the voltage difference over that resistance, 3 ohms. The current through the current source is automatically 2 amps in this direction. It's leaving node A, so I get a plus sign there. And the current through the 1 ohm resistor, this is going to be the polarity I'm going to use if this is my current direction. It's VA minus VB over 1 ohm. Those are all the currents at that node, so this sums to 0. Now, KCL at node B, I have 2 amps from the current source entering this node. I'm going to use positive currents leaving the node, so that's going to become a negative 2 amps. The current through the 1 ohm, I'm going to now redefine as being in this direction. That gives me a voltage polarity plus minus this way, and this current is VB minus VA over 1 ohm. The current through the 3 ohm resistance is going to be in this direction, assuming positive leaving node B. It'll be VB minus 0 volts, my reference, over 3 ohms. And finally, the current through this 6 ohm source is going to be VB minus 6 volts over 6 ohms. That's all my currents. Those sum to 0. This gives me 2 equations and 2 unknowns. I can solve those for VA and VB. Now I need to write an equation from which I can find the voltage V from these node voltages. V is the voltage across the 3 ohm resistor, with the upper terminal being assumed to be the positive terminal. The upper terminals at a node voltage of VB, the lower terminals at a node voltage of 0. So V is equal to VB minus 0 volts. There's my third equation. 3 equations, 3 unknowns. I can solve those for V.